Drones came onto the scene 4 or 5 years ago, and I think they really captured people's imagination with all the incredible concepts that are out there. There's this general notion of an autonomous flying camera that can follow you around and capture amazing video, but the paradigm with existing products is you essentially need an expert pilot there flying it. And if you have that, you can do incredible things, but for most people and for most applications, the potential is still a little bit out of reach. In a lot of ways, this feels like a product that we've been working on for most of our lives. I met my co-founders, Abe and Matt, when we were grad students at MIT, where our lab was one of the first in the world to develop autonomous flying systems. We worked on a fixed-wing vehicle that could use lasers and cameras to fly itself around a parking garage at high speed. And really the goal of that project was to do something that would go beyond the capabilities of even what the best pilots in the world were capable of. And at the time, it was just sort of a fun, interesting challenge to be working on, but a lot of what we learned there forms the foundation for what we've built now at Skydio. Our initial focus has been to deliver on that promise of the autonomous flying camera and to make it real. Basically to create a film crew that fits in your backpack. It's a camera that understands the scene it's looking at and has the ability to move itself. Those two things together are just enormously powerful. This is a very ambitious product, and to make it possible, we had to develop custom hardware. We built a device with 13 cameras that see in every direction, and at its core, it uses an NVIDIA TX1. It's the same thing that's found in self-driving cars, and that's what runs the Skydio Autonomy Engine. The first step in the vision processing pipeline is understanding where the vehicle is and how it's moving. To do this, we look for regions of high texture in the environment, and we track those as landmarks in the real world that we can triangulate and track our motion. That motion estimate is the foundation for everything else we do. The next step in the processing pipeline is building up a 3D understanding of the world. To do that, we compute stereo depth maps from each pair of cameras, and these get fused over time into a dense 3D understanding of the environment. From there, the R1 uses a combination of deep neural networks to understand the people around it. It knows what people look like, and for every person it sees, it builds up a unique visual identifier that it can use to tell people apart so that it can stay locked on to the right subject. The motion planning system turns all the information about the environment into useful action. So it balances avoiding obstacles, keeping the subject in view, and capturing amazing video to figure out how the vehicle should behave by predicting 4 seconds into the future. These planning commands get turned into action in the physical world in rotor speeds and gimbal angles. This is an incredibly complex system, but the end result is simple. The vehicle moves itself in a beautiful, smooth, cinematic way to capture amazing video.